Hey, Wagwan. Yeah, man, it's Mr. Garfield here. And today I'll be looking at the discriminant of a quadratic function in the CSEC additional mathematics syllabus. All right. So here I have a question which says that given the identity x squared plus ax plus b is the same as x plus p all squared plus q, find the constants p and q in terms of a and b. And then it says that we are to deduce that the equation x squared plus ax plus b equals 0 has no real solutions if b is greater than a squared over 4. Okay, now before I get into the question, let me just write a note here for you. All right, so first I wanted to recall the quadratic formula. All right, so recall that if we have the equation, the quadratic equation, ax squared plus bx plus c is equal to 0, then the solutions to this equation are, or should I say is, the solution to this equation is x equals negative b plus or minus the square root of b squared minus 4ac, all right? And then what? We are dividing all of that. We're going to divide all of that by 2a, all right? So you should remember that, which is the quadratic formula. Now this expression here that is underneath the root, that value, which is b squared minus 4ac, that constant is what we call the discriminant. All right, so I'm just going to write a note here for you. So I'm now going to say d, all right, capital D, which is equal to b squared minus 4ac, is called the discriminant. Is called the discriminant of the quadratic equation ax squared plus bx plus c equals 0, where a, b, and c are constants, but the value of a must not be equal to 0, right? So a, b, and c must be constants, but a cannot be equal to 0. Good. So d, which is equal to b squared minus 4ac, is what we call the discriminant, and that is the value which is underneath the root in the quadratic formula, as you can see above, which is highlighted. All right. So there are some things that you should remember about this discriminant. Okay. So let us say that the value of d is positive. All right. So if d is positive, or we say greater than 0, then it means that we have distinct roots. All right. It means that we have distinct roots, meaning that the roots are different. All right. Or we have different solutions to the quadratic equation. All right. So that's one. Now, what if this value of d is equal to 0? What would happen? So if b squared minus 4ac is equal to 0, then we have repeated roots. All right. So repeated roots just means that we have we really have one root, right? So for example, you might get x is equal to -3 and x equals -3 again, right? So those are repeated roots, or we could say equal roots instead of repeated roots, all right? In the first case, where we have distinct roots, it could be something like x equals 2 and x equals 3, all right? And there's one more case, which is what we're focusing on for this question. If the value of d is less than 0, right? So if b squared minus 4ac is less than 0, then we have no real solution, all right? So it means that we have no real solution, all right? So just to be clear, we do have a solution, but it's just not a real number solution, all right? So you will learn how to find solutions when the discriminant is negative whenever you go into higher level mathematics, right? Such as the K-pure mathematics, or if you will choose to study mathematics at the undergraduate level. Okay, now let's get into the question. First, it says that we are to find the constants P and Q in terms of A and B, all right? So what we want to do first is to write the quadratic that is on the left-hand side of the identity as x plus p all squared plus q. We want to write it in that form, all right? And notice that this form here, the way that the quadratic is written in, this is what we call the vertex form, all right? The vertex form, so it means that we have to complete this square for this quadratic, okay? Let's do that here. So I'm gonna start my solution to this question now. So I will have solution. So we want to complete the square for x squared plus ax plus b. Okay? So you already know how to complete the square. Some of you might do it differently than I do, but I will explain the process as we go along. So I'm going to write back the same terms here. All right. Normally, if there was a number in front of the x squared, we would factor that number out first from the three terms. Okay? But in this case, the coefficient of x squared is 1. So in that case, what we will do is write back the first two terms, and then I will add and subtract a constant. Okay, so I'm going to add a constant, which is going to be a half of the coefficient of x. So it's going to be a half of a, or a over 2, squared. All right, so I'm going to add and also subtract that same constant. So I'm going to write back the b first, and then subtract a over 2 all squared. Okay? Now by doing that, it means that I will have a perfect square. So let me just simplify first. So what we will get is x squared plus ax plus a over 2 all squared is the same as a squared over 2 squared, which is 4. All right, whenever you take the square of a fraction, it's the square of the numerator divided by the square of the denominator. All right, plus b minus a squared over 4. Excellent. So these three terms here, the x squared plus ax plus a squared over 4, that gives us our perfect square, which is going to be x plus the constant in the brackets here, all right, the constant in the brackets here, a over 2. So it's going to be x plus a over 2 all squared. So that's our perfect square there. And then I'm going to simplify this plus b minus a squared over 4. So when I add those two together, I will get 4b minus a squared over 4. All right. Great. And that is the completed square form or the vertex form of the quadratic x squared plus ax plus b. Great. So now that we have the vertex form, we need to find p, the value of p, and the value of q. Now remember that they said that they want us to write x squared plus ax plus b in this form, right? X plus p all squared plus q. So if we compare it to the identity above, we can see that the value of p, so I can say therefore the value of p is equal to a over 2, right? And the value of q is equal to 4b minus a squared over 4. All right? Great. So that is what we have. So now that we have that, we can go on to the second part of the question. So we have now found the values of p and q in terms of a and b. And it says to deduce that the equation x squared plus ax plus b equals 0 has no real solutions if b is greater than a squared over 4. Now, how do we show that part? Well, let us look at it this way. All right. We know that x squared plus ax plus b must be equal to 0, right? But remember that we had just showed previously, right up here, that this quadratic here on the left-hand side of the equation is the same as x plus p r squared plus q. And we already found the value of p and q, right? So I'm just going to write this quadratic on the left-hand side in its vertex form, which we have just written as x plus a over 2 all squared plus 4b minus a squared over 4, all right? And that must be equal to 0. Good. Now I'm going to solve for the value of x, all right? And the first thing I'm going to do is I want to get rid of this 4 here in the denominator. So I'm going to multiply each term on the left-hand side by 4, and I'm also going to multiply the right-hand side of the equation by 4. And if I do that, I will get 4 multiplied by x plus a over 2 all squared plus, if I multiply 4b minus a squared over 4 by 4, the 4 will cancel out in the denominator, leaving me with 4b minus a squared. And that must be equal to 0 multiplied by 4 will still give me 0. Good. So what do I do now? I'm still solving for the value of x. So I'm going to carry this 4b minus a squared to the right-hand side of the equation. So it means that I will have to change a sign, right? Change the signs here. So what I will have is 4 times x plus a over 2 all squared is equal to, now if I carry the negative a squared to the right-hand side, it becomes a positive a squared. And if I carry over the positive 4b to the right-hand side of the equation, I will get a negative 4b. Excellent. All right. Now I'm going to divide both sides of the equation by 4 to get rid of this 4 as the multiplier on the left-hand side. So what I will have now is x plus a over 2 all squared is equal to a squared minus 4b divided by 4. Okay, good. So that is what I have. Now, to get the value of x, what I will need to do here is to get rid of the square on the left-hand side, right? So in order to do that, it means that I will have to take the square root of both sides of the equation. So what I will have is x plus a over 2 all squared. All right, I'm taking the square root of that, and that must be equal to the square root of a squared minus 4b over 4. Okay, great. Now remember that a squared minus 4b all over 4 is just a constant, right? And whenever we take the square root of a constant, it means that what I will have is plus or minus in the front. Okay, good. So continuing, so the square root of x plus a over 2 all squared will give me x plus a over 2, and that is equal to plus or minus. Now, whenever we take the square root of a fraction, you should remember from surds that whenever we take the square root of a fraction, it means that we have to take the square root of the numerator and the square root of the denominator, right? So the square root of a squared minus 4ab all over 4 is the same as saying the square root of a squared minus 4b all over the square root of 4, which is 2. All right, excellent. So I'm almost there. I have x plus a over 2 here on the left-hand side of the equation. So I want x by itself on the left-hand side. So I'm going to carry this a over 2 to the right-hand side, right? So I'm going to subtract a over 2 to both sides of the equation, which would leave me with x equals negative a over 2 plus or minus the square root of a squared minus 4b all over 2. All right, good. Now, clearly we can see that these two fractions have the same denominator, which is 2. So since that is the case, it means that I can combine the numerators. So therefore, x will be equal to negative a plus or minus the square root of a squared minus 4b all divided by 2. All divided by 2. Excellent. Now this looks a lot like the quadratic formula, right? So this equation here is indeed the solution to the quadratic that was given to us as x squared plus ax plus b. All right. Now, what is the discriminant? The discriminant of the quadratic that we were given in the question is this, right? It's always the constant which is underneath the square root. Okay. So it means that our value of d is a squared minus 4b for the quadratic equation x squared plus ax plus b equals 0. So what I'm now going to say is I'm going to let the value of d, which is our discriminant, as the value underneath the root a squared minus 4b. Right? That's our constant. Now, remember that the question says, let me go back to it. The question says that we are to deduce that the equation has no real solutions, right? Remember this word, no real solutions, if b is greater than a squared over 4. So if this quadratic here has no real solutions, what does that mean? It means that the value of d must be less than 0, right? It means that the value of d must be negative. So I'm now going to write a statement here. Okay, I'm now going to write a statement here and say if the value of d is less than 0, then we have no real solution. All right. So if the value of d is less than 0, then we have no real solutions. Good. So in other words, right? In other words, what I'm saying is that the value of d, which is a squared minus 4ab, that must be negative, right? Less than 0, in order for us not to have any real solutions. So I'm now going to solve this inequality for b, right? So I'm going to subtract, a squared to both sides of the inequality, and I will get negative 4b is less than negative a squared, right? And I can now get b by dividing both sides of the inequality here by negative 4. And if I do that on the left-hand side, I'm left with b. And on the right-hand side, I am left with a squared over 4. Okay? Now, let me ask you a question. Are we going to put less than here as our inequality sign, or is it going to be greater than for our inequality sign? What do you think? Well, if you said greater than, then you are absolutely correct, because we have to change the sign of the inequality once we divide or multiply by a negative number. In this case, we're dividing by negative 4, so it means that we have to reverse the inequality sign. Okay? So b must be greater than a squared over 4, and that is what they wanted us to show. Right? Here it is, b is greater than a squared over 4. Okay? So that is the solution to this question. All right? So we're going to use the discriminant of a quadratic equation. Okay? So remember that when you have the discriminant, it tells you whatever solutions you are to get. Right? It tells you the type of solution, whether it's going to be distinct solutions, right? Or repeated solutions, or no real solution. Okay? So I hope that this video was helpful for you. And if it was, please ensure to like this video and subscribe to the channel. I am Mr. Garth Reed, Student Ambassador for the University of Technology, Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.